after a devastating grip of wildfires swept through the country, killing dozens of people.
We are working on preventing this from happening again. We are students from the National Polytechnic School of Algiers from different engineering domains and backgrounds. We worked on creating a data-driven solution that could help in estimating fire spread, so that needed precautions can be taken to limit and control any eventual risks. Our work is titled Applying Semi-Empirical Simulation of Wildfire on Real-World Satellite Imagery Data. Let me explain that. After reading many research papers, we found that during the past 20 years, many models of wildfire propagation have been created. These models can be divided into three large groups: empirical, semi-empirical, and physical. We were able to combine between different models to come up with an equation that approximates the behavior of wildfire propagation. The three main factors that contribute to this equation are the slope of burning land, type of vegetation that acts as fuel for the fire, speed and direction of wind. This is what the final equation looks like. Our goal is to perform a numerical simulation with this equation, but in order for the simulation to be relevant and useful, it needs to run on real-world data. Satellite imagery is exactly what we need here. Satellite imagery comes in the form of rasters. Rasters are matrices of pixels, where each pixel contains values representing information about a specific location. Data stored in a raster represent real-world phenomena, such as surface reflectance, temperature, elevation of land, and weather information. With the use of Earth Engine Python API and machine learning techniques, we were able to segment reflectance rasters in order to specify the type of land in each location, whether it's a bush, a forest, a water body, or just soil. Now, the data is ready. By creating a 3D model for the topography of 129 square kilometers of the coast side between Cap Jeannet and Tixert, we were able to apply the propagation equation discussed before in each location on this coast side. Combining this with the cellular automata, our simulation was up and running. Now, we can estimate the propagation of fire on this land in any location. This estimation can help in planning firefighting strategies in advance, which will enable fire crews to position equipment on the ground in an optimal manner, minimizing damage and staying safe. Planning strategies in advance will eliminate any possibilities of crews being trapped by fire. It can also help in locating critical zones so that firefighters can focus on areas with higher risk and develop better infrastructure as a precaution to gain more control over these zones.